Swayam Prabha. Digital India. Educated India.
In this and some of the following lessons, we will look at a very useful circuit block known as the operational amplifier or the Opamp. It is really a control source, but when it is used like an Opamp, it has certain properties which makes it very useful, and that is why it is used very widely. So, we are going to look at certain Opamp circuits and also how to analyze Opamp circuits in general. Okay. It is frequently abbreviated as Opamp. So, what is it? It is denoted by the symbol. So, it has two inputs, that is, if we assume that there is some reference node here, then we have V 1 and V 2 at its two inputs. That means that V 1 is the voltage between this point and ground, V 2 is the voltage between that point and ground, and V 0 is between that and ground. And this V 0 is A 0 times V 1 minus V 2. Okay. So, typically this difference between V 1 and V 2 is denoted V D. So, V 0 is dependent only on the difference voltage between its inputs. Okay. So, that is what an Opamp is. Now, looking at this definition, it will be obvious to many of you that this is nothing but a voltage controlled voltage source. Okay. Now, the voltage controlled voltage source is such that the controlling voltage between its terminals is denoted V D, and the controlled source is A 0 times V D. Okay. And one of the terminals of these control sources, the bottom terminal as I have shown here, is connected to ground, which is the common reference voltage, and this happens internally to the Opamp. This is not a connection that you make. So, these three terminals are available to you. This is denoted plus, that is denoted minus, and this is the output. Okay. So, this is the plus terminal as it is marked inside. This is the minus terminal as it is marked inside, and that is the output terminal. Okay. So, this is what an Opamp is. It is a voltage controlled voltage source. So, what distinguishes an Opamp from a general voltage controlled voltage source? The point is that this A 0 is supposed to be very large. Okay. So, an Opamp is a voltage controlled voltage source with a very high gain. Okay. What is very large depends on the context. It could be that in some context 100 is large enough, or in some cases you need a million. Okay. So, the point is that it is very large. In fact, frequently we take the limiting case of A 0 being infinity, and in one of the following lessons we will deal with the case when A 0 is infinity. Okay. So, what can we do with this? What does it mean? So, this is a voltage controlled voltage source. This means that this voltage is V 1 with respect to ground, this is V 2. So, what does it mean for us to have a voltage controlled voltage source with a very large gain? This means that if V 1 is larger than V 2, that means that this V 1 minus V 2, this is positive, or this V D is positive. So, if V 1 is more than V 2, it means that the output V 0, this voltage is driven strongly positively, because A 0 is very large. For a small positive difference V 1 minus V 2, you will have a very large positive output. Okay. So, for now I will describe it as the output V 0 driven strongly positive. Okay. And similarly, if V 1 is smaller than V 2, then this difference V 1 minus V 2 is less than 0, this V d is less than 0, and the output V naught is driven strongly negative. Okay. So, this is an important feature of the op amp, and this is what we will use to realize a very useful class of op amp circuits based on negative feedback. Okay. So, what does negative feedback mean? First of all, feedback means that you somehow drive the output after looking at the output, comparing it with some desired value and making some computations. That is what is the meaning of feedback, right. Feedback means that you look at what the output is before you do something to change it. The contrast to this is open loop control, where you set the input to something without looking at the output. Okay. So, I will give you an example of driving a car. An open loop control is when, let us say, you do not have a speedometer at all. Okay. So, if you have some strange vehicle without a speedometer, then to go at a certain speed, you have some vague idea of the speed you want to go to, and then for that, let us say you press the accelerator down to a certain extent, maybe halfway down. Okay. Now, you have no idea what the speed is, you just get whatever the vehicle gives you. Okay. If you press the accelerator halfway down, it will go at certain speed, and that will depend on the properties of the vehicle, maybe of the road, the friction, the accelerator and all of that stuff. Okay. Now, in contrast to this, a closed loop control is when you are actually measuring the speed, that is the normal thing where you have a speedometer which tells you what speed the vehicle is going at. So, you look at the speedometer and then you make adjustments to the accelerator, you adjust how far you press down, so that it goes at a desired speed, let us say 50 kilometers an hour. So, clearly in one case you are looking at the output, that is the second case, when you are looking at the output you are operating in feedback, whereas in the other case where you did not have any idea of what the speed is, you just press down the accelerator halfway down, you are an open loop system. Okay. Now, it is very clear that if you have feedback, you can set the speed lot more accurately than if you have an open loop system. That is the motivation for realizing negative feedback systems. Okay. Now, in our case, we want to make an amplifier, let us say. So, in my case, I want to make an amplifier using negative feedback. That means that V naught should be equal to k times V I. Okay. I will just recast this relationship as V naught by k should be equal to V I. Okay. Now, how does the op amp help me? What I will do is the following. I sense V naught by k. Okay. How I will do it? I will show it to you in a short while. If V I is more than V naught by k, I strongly drive up V naught. Okay. V naught is the quantity I want to control, it is my output, whereas V I is the input. So, if V I is more than V naught by k, that means that V naught is too little. So, I will strongly drive it up, so that it goes in the right direction, and if V I is smaller than V naught by k, I strongly drive down V naught. So, if V I is smaller than V naught by k, it means that V naught is too high. Okay. So, I have to drive it down. Earlier I described the op amp as something that strongly drives the output positively if V d is greater than 0 and negatively if V d is less than 0. Now, you see that it essentially accomplishes what we are looking for over here. Okay. So, an op amp which is a voltage controlled voltage source with a very high gain can be used to realize this amplifier. So, how do I do that? The output of the op amp must be V naught, okay, and it must be driven up strongly, that is it must be driven strongly positively if V I is more than V naught by k. Okay. So, I have to apply V I to one terminal and V naught by k to the other terminal. Okay. So, with this polarity the op amp responds to V I minus V naught by K. My difference input voltage V D is V I minus V naught by K. Okay. And similarly, if V I happen to be smaller than V naught by K, the op amp will strongly pull down V naught. Okay. It will drive it strongly negatively. So, this is exactly what we want. The only thing we need to do in order to complete the circuit is we have to somehow obtain this V naught by K, which is a fraction of V naught. Remember, we are realizing an amplifier. So, this K is more than 1. So, V naught by K is smaller than V naught. Now, it is very easy to derive a smaller voltage from a larger voltage. Okay. You can do that using a resistive divider. Okay. So, if I realize a resistive divider like this, where the upper resistor is K minus 1 times the lower resistor, the voltage that I get over here is V naught by K. So, that I take and connect over there, where I wanted V naught by K. So, this completes my circuit. Okay. So, I derived the circuit from the idea that if V I is more than V naught by K, I should drive up V naught strongly, and if V I is smaller than V naught by K, I should drive down V naught strongly. And I had a block, an op amp, which is a voltage controlled voltage source with a very high gain, which does this business of strongly driving up or strongly driving down the output. So, I have realized it like this. Okay. So, now we can use our circuit analysis machinery to see exactly what this does. Right now, I derived it based on some intuition and negative feedback, but we can use our knowledge of analysis to figure out what it does. Okay. Initially, if you are a little bit confused with the op amp symbol, you can substitute it with the controlled source symbol. This is A naught V D and this voltage is V D. I have not done anything here. I have simply substituted the op amp with the control source. The 3 terminals of the op amp here, here and there correspond to this one, that one and that one respectively. Okay. Now, this is a very simple circuit to analyze. The output voltage here V naught is A naught V D and V D is the unknown, but V D we know is V I minus V naught by K. Okay. So, this difference here is V I minus V naught by K. Okay. So, the output voltage V naught is A naught times V D, which is A naught times V I minus V naught by K. Okay. So, by taking terms containing V naught to the other side, I get this ratio V naught by V I to be A naught by 1 plus A naught by K, which can also be written as K by 1 plus K by A naught. Now, what did I want? My original goal was to realize an amplifier of gain K. So, that means that the desired function is V naught by V I equals K. Now, what I have is not exactly this, but that one. But by inspection you see that this will be approximately equal to K if K by A naught is much smaller than 1. Okay. So, this is where the significance of A naught being very large comes in. The op amp has a very large gain A naught. So, this K by A naught is much smaller than 1 if K is some modest value. Let us say A naught is 1 million and your K is 100. So, K by A naught is 1 by 10,000, which is a very small value compared to 1. Okay. So, in that case, the gain of this amplifier V naught by V I, which is K divided by 1 plus K by A naught, can be approximated by K. Okay. So, this is true if op-amp gain A naught is very large. Okay. So, this is the reason we need a very large gain in the op-amp. The gain of this amplifier is K, which depends only on ratio of resistors. Okay. It depends on this resistor and that resistor. Okay. So, this is an amplifier using negative feedback using an op-amp, okay, and it gives us a feedback controlled amplifier of a gain which is very, very close to K. Okay. So, some quick comments on this circuit. I have set the resistance value, the upper one to be K minus 1 R, the lower one to be R, okay. And the actual gain of this is K by 1 plus K by A naught, where A naught is the gain of the op amp. It means that if this difference voltage is V D, the output V naught will be A naught times V D. Okay. And if A naught is very, very large, this gain is approximated by K. Okay. This is if A naught by K is much more than 1. Okay. So, in that case the denominator becomes approximately 1 and the gain is just K. Now, this particular circuit, it is a classic op amp circuit known as a non-inverting amplifier, and very frequently you see it in textbooks with a slightly different notation for resistors. This is called R2 and R1. Okay. The circuit is exactly the same. So, R2 by R1 is nothing but the ratio of this resistor to that resistor, which is K minus 1. Okay. So, the gain of this non-inverting amplifier, when I denote the two resistors as R2 and R1, is V naught by V I. The same formula holds. The only thing is I have to express K in terms of R2 and R1. Okay. So, clearly from this we see that K is 1 plus R2 by R1. So, the gain is 1 plus R2 by R1 times 1 by 1 plus R2 by R1 divided by A naught, which is approximately equal to 1 plus R2 by R1 if the op amp's gain A naught is very large. Some of you who are familiar with op amp circuits would already be familiar with this formula. What I showed you is how this negative feedback circuit is derived. Okay. It operates based on sensing the output, sensing a fraction of the output, comparing it to the input and driving the output strongly up or down based on the difference. Okay.